How do we future-proof the revenues of utility-scale solar plants, given all the changes that will come over the next 20 years in market side as well as in the regulatory side?
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome to another edition of the Insider's Guide to Energy. I'm your host, Chris Sass, and with me today is Debrup, head of North American Renewables for Hitachi. Debrup, welcome to the podcast.
Thank you, Chris. Excited to be here. Thanks for having me.
I'm excited. This show has been in the making for quite some time. I think we spoke a long time ago about getting you on the show. And, Hitachi's doing quite a bit in renewables, and it's an interesting space. Why don't we start with a little bit about what you're working on?
Sure. Maybe I can talk a couple of sentences on Hitachi Energy itself, because I am sure most of the audience know about us. But maybe for those who doesn't, we are original equipment manufacturer, or OEM. So we make electrical equipments that goes into the grid, whether it's on the utility side, whether it's on the developer side, and so on and so forth. And we are a global company in almost 90 plus countries, with almost 50,000 employees worldwide, more than 6,000 in US. Bring the technology, the electrical piece that really helps the grid modernize. And we know that the society is moving towards electrification. So we are helping, we are very proud to be helping in that transition.
All right, so you have very ambitious goals. You're a large company. Anyone in the energy, probably most of our audience have heard of you and know where you place. In our pre-conversation, we talked a bit about renewables and where they fit into this whole backbone and this electrification scheme. And it'd be interesting to see, your personal take as a subject matter expert of how renewables are going to play out here. Now, everybody's talking about them, everybody wants them, but where do they fit?
Absolutely. Yes. So, of course, the renewable goes into the generation piece of it. But before that, maybe let's take a step back on the demand side, because that's what driving the whole conversation, right? If we look at the demand, what's the demand on the electricity side? The whole society wants to go towards electrification, which means that the transportation sector, for instance, is going towards electrification. And now, of course, the AI and machine learning piece is adding to that. So this is driving a growth in electricity that is unprecedented in the past 50 plus years, right? And to support that, now we need to meet it with our generation side, which has renewables and, of course, the other pieces of the puzzle. Now, what it gets interesting here is if you look at the economics piece of it, the renewables today is the cheapest way and the fastest way to meet this unsatiable demand of the grid. And that's where we come in to provide the technology in terms of connecting to the grid and making it more green.
All right, so you're claiming here that renewables are the best economic choice to get energy in. And now help me understand this. I want to put a huge data center in. I want to have AI capabilities, so I need thousands and thousands of servers perhaps, and I need cooling and all the pieces that go with it. So does this mean that I need to plop my data center down somewhere in the Sun Belt and it's only going to work during daylight hours?
No. We have come a long way to make sure that we have future-proofed, or we have made our grid and our technology modern enough so that we only don't use it when the sun shines or the wind blows, right? So that's the piece we bring in terms of making the grid stable and so on. So yes, you're right. When it's a data center, we're talking of huge loads now, hundreds of megawatts, gigawatts, in fact, in many cases. So of course, now we have to make, if we look at the economic piece of it, the renewables. Let's say if you take solar in particular, right? In the LCOE analysis of Lazard, it puts it as the cheapest form of electricity over the life cycle of it, even cheaper than some other forms that we have known for the various tens of decades. So when we connect, when we are thinking of serving this energy, of course, there's a piece of energy in the form of solar and wind that will help us meet this demand. But there'll be also other pieces of the puzzle, for example, battery energy storage or long duration energy storage, which many people are still researching on. So there'll be also other pieces of the puzzle which will ensure that the grid is stable not just when the sun is shining or the wind is blowing, but also during the night hours, during the hurricane, and so on and so forth. So all this together enables us to uh, meet the demand of the data center. Now, the location, whether it's in the sun belt or whether it's close to a coast, there is a lot of factors that goes into evaluating of that. So it's not. I wish it was a straightforward answer for you, but it's not such a one-line answer because it has to look at various aspects, not just of the energy, perhaps, but also, as you said, it needs cooling, so water, other infrastructure, connection to the people who will be using it, and so on. So, but from the energy perspective, we certainly have the technology today to make sure that the renewables help in this transition to the AI, which is very, very power hungry.
All right, so we're talking about the technology. We also recently have seen interest in nuclear grow, and if you look at these data centers and the kind of demand, so I hear you saying solar is there. Why are we not leaning on nuclear? What's the gate? We got these modular reactors that are coming. There's all kinds of interesting technology there. Are you
Sure.
still saying that solar is the way to go, or is it a mix and match, or what's the answer you're seeing?
Yeah, I mean, it's definitely a mix and match of all of the above. I think it's not a question of one or the other. But having said that, I'm not a specialist in nuclear side. But from at the high level, what I see and hear, it has still perhaps 10 plus years to come to the market. So there may be some barriers in terms of technology, in terms of safety, and so on, that needs to be overcome for us to be comfortable with it and go into the full scale. So what we are seeing right now is renewables such as solar and wind. They're ready today, and they can go up today to meet the demand of the whether it's the transport industry, whether it's the machine learning industry, and so on and so forth.
And in your previous answer, you described these hybrid energy plants where you talked about solar storage. What's happening there? What's the trend in that? I mean, you implied that storage is there. You said there's still research being done on long duration storage, but help me understand how it's working today and where we are.
Absolutely. Yes, this is an interesting thing that we are seeing, trend that we are seeing. In the US, we are seeing a lot of storage being co located with solar. So often, when we see a solar plant, utility scale solar plant, it will have 1 to 4 hours of energy storage in that plant at the same location. Last year, Woodmac estimated that about 50% of such storage solar plants had storage. Now, just this quarter, it's up to like 66%. So it's definitely an upward trajectory. And here, the interesting factor is once the developer puts storage in the solar plant, we see additional value streams, additional not just on the financial side revenue stream, but also an additional value from the technology piece, which can help bring lots of ancillary services, for instance, to the grid, which can make the grid stable and so on.
And then what percentage of solar projects take and put storage with them? Is that a high percent or a low percent today?
It's pretty high in US. So last quarter it was as high as 66% of solar. If you look at megawatt wise, the amount of megawatts or gigawatts we put it in solar, almost 66% of them had a storage element to it. So which means that we are more and more going towards this hybrid. In Europe, there is a slightly different term. They use energy hubs, which is often used for co-located, and it can be co-located generation. It can be co-located with storage, co-located with hydrogen, for instance, and so on. So we are seeing an upward trend towards having these energy hubs or hybrid facilities, if you will.
Are we also seeing storage used for peak shaving or for other opportunities where it might be to a more conventional energy plant where they can take capacity and put it into storage? Is that something that's taking place in scale?
Okay, so hybrid plants. It's a very interesting concept that we are getting more and more popular. So what we are seeing is today in a lot of markets, for example, California and Texas, there's a lot of congestion or curtailment. So what happens is if the utility upstream has an overloaded transmission line, then as a solar plant, you cannot put more solar energy even when the sun shines. In fact, if you look at the KISO market, the curtailment has gone more than 7x in the last 5 years in terms of energy that is curtailed. So what we are seeing here is the batteries. They give the capability of these solar to these storage plants, solar plants, to store the energy for a few hours. So when the congestion in the grid clears up, they can then now feed the power to the grid. So that way, we are not wasting the solar energy that is being generated.
Okay, so I get that we're not curtailing the energy, and that we don't want to, just get rid of the energy, so we're saving it. But are folks using this for economic advantage? Is this changing the way our market and our immediate demand for power is being used? So are there market dynamics where I can take that stored energy and do the economics work and then sell it back when prices are high? Is
Yeah,
that happening?
that's a great question. That is not happening as much, but I can tell you this way: like if we, when we come into the picture, we certainly help our customers, the developers, to future-proof the design. Yeah. So if I look at a solar plant, and let's keep hybrid aside for a moment. If I look at a solar plant, it's a very high capex project. So the all the capital goes in almost in year one, right? And then we have to recoup the revenue over the next 20 years. So we really want to make sure that this project is de-risked in terms of finance, which we'll talk about, in terms of the market, the utility grid changes that comes along with it, and the third piece is the regulation piece. Yeah, and let's go one by one into it. So the finance piece, right? So as I was mentioning, that it's a high capex project, and we have to get the revenue over the next 20 years, right? So of course the market prices in the energy market will change, and so on and so forth. The price signals in wholesale market, PPA market, the ancillary market will change. How do we de-risk it? Today, not many people are taking advantage, for instance, of participating in different markets. Today, it's more PPA, but that's where we come in to educate our customers that, hey, if you build in the flexibility when you're designing the systems today, then you could participate in the market if and when that becomes a more attractive proposition
So
for you.
what's the gate of that? Why are we not seeing people being more market participant and motivated by short term, 15 minutes or short windows of opportunity? What's gating them today?
It's a little, I mean, remember, a lot of these solar plants that are installed today have been designed maybe 5 years back. So a lot of times they might not have thought of the possibility. And in many markets, in certain markets, these price signals may not be as strong. The PPA prices that they have is the main way that they make money. So here, that's where we come in again to make sure that we learn from our trajectory and make sure that what we're designing today is really making full advantage of the flexibility that we can incorporate in the design. And hence, if things changes, if market signals become really attractive, let's say in the ancillary market 5 years down the line, then the developer has the capability to move things around in a certain way and hence take advantage of it.
From the infrastructure point of view, I mean, we talk about the grid like it's one thing, but
Yeah.
it's not this one thing. There's a lot of regulation. There's a lot of rules connecting. How is that developing, and where are we today? If I'm a solar developer, and let's say there's a number of people trying to place capital and develop as quickly as they can, and I'm in a region, how's the regulation supporting? Who gets to go in? How's the grid remain stable? I mean, there's a lot of elements there. So help me understand that picture. How do I take my development, get it approved, and keep the grid stable?
Absolutely. That's, I think, the critical piece in the technology aspect of it. So there is something called the grid code, which in layman's term, we can call it that as the electrical code of conduct. So if utility is the school or the university, so if you want to get admission to that school or the university, you have to abide by the electrical code of conduct. And hence, when a power plant is connecting to the grid, it has to make sure that it understands all its responsibilities in terms of, hey, what happens if there's a disturbance in the grid? How do I support the grid? What happens if there's an outage? What happens if there's an internal issue, if equipment failure, and so on? So all these are very critical pieces that has to be designed upfront so that they abide by the grid code. Now, if you look at grid code itself, it has evolved in the last 10 to 15 years significantly. Of course, if you think back 15 years, there's not much solar that was connected to the grid. And hence, the requirements for the solar plants were very rudimentary. Disconnect if there's disturbance, don't worry about the grid, just take care of yourself. Now, it's bigger play in the grid. So now it has to have a bigger responsibility. So when there's a requirement, it should support reactive power to the grid. It should make sure that the grid is stable and so on and so forth. What we can project is this requirements will grow even stronger as solar plays a bigger role in the electricity grid. Right? So how do we make sure that, again, designing today and implementing today, the utility scale solar plants are able to abide by the grid codes, which may be changing in the next 5, 10, 20 years. So for sure, in some markets, for example, grid forming inverters might come into the picture and so on.
I guess, if I think of the grid that we grew up with, you think of a base load, you think of the market demand, and then spinning up generation based on a bidding process of whatever the price is to spin up whatever resource it is. Now, solar, I mean, that's very different, isn't it? And how that goes. So, let's create this, let's loop them together into a virtual power plant, so to speak.
Right.
How does that work? I mean, if load, it's 5 p.m. or 6 p.m. and people are coming home, turning on their stoves, turning on their ovens or whatever, or if you have a steel smelter in your region and they need power at certain times, how does that different architecturally and performance wise than the grid of base loads and then the market kind of just spinning up new generation?
Sure. And there are two angles to it, and we need all of these tools to make sure it works. One piece of it is in the generation itself, what you do when the solar goes down, and the other piece is in the grid infrastructure itself. Yeah. So to answer the first, to look at the first box, if you look at solar and wind, for example, they're very complementary. The wind starts blowing stronger during the night, right? So, in some sense, if you look at the various forms of renewable energy, they complement each other very well. And storage really helps a lot. Yeah. So, right now, most storage are 1, 2, or 4 hours, those duration. But as I was mentioning, there's actively research and demonstration going on for long duration storage. So, at certain point, I'm sure we will see maybe 10 plus hour, maybe even 100 plus hour storage that becomes reality. That will help more make things even. So that's the generation piece of it that helps smooth things out. There's also the transmission and distribution piece of it, where increasingly we have to make the grid more agile, more adaptive, so that we can make sure that we can connect the various parts where the solar is, which is often a little bit far away from where the demand is, for example, right? And make sure that we can connect it in ways so that there is the grid is still stable, there's no congestion, and so on. So I think we will see already. We are saying, for example, the grid being more agile, having more controls in the forms of, for example, high voltage DC, HVDC, having support systems in the form of STATCOMs and so on and so forth, so that the grid, which sits in the middle between the generation and the load, can now actively control that, hey, during the day, I will bring the power from the solar to the load. During the night, I'll bring the power from the wind to the load, which geographically, which these two are different regions.
Now, as you're describing that, my mind started thinking through kind of the simpler, as I like to say, the dumbass question that I'm never afraid to ask on this podcast. In your opening, you talked about the demand increase for electrification. And in this podcast, we've talked about electrification of pretty much everything. That's kind of the move, right? And what I see are some of the changes coming. Things like if EVs were prevalent, take all the fleets and all the EV demand, and then you take heat pumps and you start changing because heating is a large use of energy, and you electrify all that. Does that change the dynamic of the grid that we know? Because peak demand is during the daytime is today, and at night you might charge your car. But as we get more and more EVs, everybody can't go to that cheap 3 a.m. charging time, because if everyone's doing it, the demand is now high at night. And if everyone's house is heated by electric, the demand which would have curtailed during the evening hours might go up. So have we seen a shift? And are we expecting to see a shift in power? So it's not just the peak, It's the duck curve different? Is it different than what
Yes.
we expect?
Uh, yeah, I mean, I wish I had the future-looking globe, but yes, it will evolve differently. That's for sure. I think uh, how it might evolve in different markets, it's still a big unknown. We will have a lot of different types of demand curves through the day and so on. As you mentioned, like we are used to thinking in a base load fashion that hey, we have the base load, and then in the night the requirement goes up, and the day the requirement goes down when everybody leaves for offices and so on. And we have seen in California already the duck curve is a really inversion of what we expected in the last 100 years, right? Uh, Once we go towards more electrification of EVs is a big piece of it. Yes, it will change the demand during the night. um, I think what we cannot also discount is the personal EVs is just one fraction of the transport industry, right? So we see more and more electrification of the big units like the trucks, the school buses, the mining trucks, which are significant amount of power per unit, right? So as we go electrify those pieces of the transportation industry as well, I think we will totally see a different diurnal curve, a totally different weekly curve. How that might look like, I don't know. I wish I had the.
But I guess what it brings to my mind is the importance of hardware and software rules and enforcement of how one could build infrastructure that could evolve with that.
Yeah,
From where you sit, how is the technology evolving to make that possible, right? Because it's a dynamic shift. I mean, it's almost a 180 shift if the vision that I heard you say has taken place. And, if I'm building infrastructure for the next period of times, if I'm building a new development today, help me understand how I comply with the code that you talked about today, but have the policy enforcement to be stable 5 years from today if there's a major transformation, or 10 years from today.
yeah. So I think there are two components to it. One is probably the vision aspect that hey, how do we see the evolution of the grid and the interaction between the players, right? Let's go into that first, and then the second piece is uh, if on a take an example of a solar plant, and how do you make sure that in that vision you have the right tool sets to play with, right? So yeah, so let's take the vision aspect first. I think it's a what we will see is this high interaction, right? Today, as users, you and me, we just switch on the microwave, the dishwasher when we need, and for most markets, we are not charged by the hour. For most markets, we are just charged, hey, this many kilowatt hours is your demand, and hence a multiplier factor and so on. But I think it is already becoming more interactive in some sense, that as users, we have the responsibility to understand or and adapt when the energy is more abundant, and accordingly change our usage. Yeah. So of course, it trickles down less to the personal side. But when we look at CNI operations and so on, it's clear that hey, these users have to be more adaptive. That hey, does all my power needs to be on all the time, or this is some amount of my load that is flexible, and hence I would try to have that when the prices are low. So that way it's a change in behavior as a society, not just on the personal side, in the industrial side and commercial side. How can, as a society, we evolve that hey, energy is precious, we should not waste it, we should use when it is more available, and hence as a society we become more interactive, that hey, right now the sun is shining brighter, so some of my off-peak non-critical things can be done automatically. Now of course nobody is going to switch on switch off 2000 things in a day, so they will automate some of these and most of these, right? So there's a piece of automation and digital that comes into the picture, which will help automate it so that the entire society is in some sort of a harmony in some sense. So does that make sense?
It does make sense, and I got that. So we kind of cover the technology,
Yeah.
and we got just a little bit of time left. I'd be curious about the supply chain. One of the things that also comes up with the renewables and people talk about is, do we have the supply chain to build everything out that we need, right? Is there enough of the type of metal we need from the right countries and the right places, or can we source all these bits and pieces? So what are you seeing taking place as a supply chain today?
Yeah, this is again a very critical piece of question today, because what happened globally is all the countries are moving towards electrification as we speak. So that put a really big strain on the supply chain, especially during COVID, and we are still have improved a lot from there. Uh, yes, we will need a lot of more transformers, a lot of more breakers, and a lot of more electrical equipment in general. And I think we have the right resources to source it in the right way. Uh, Now, we of course cannot. For any global company like us, it's very inefficient to say, hey, we should all produce it from a particular geography. So we have to be cognizant of the fact that, hey, what makes the most sense? Which components should be manufactured where, and how do we source it strategically, keeping in mind the aspects of national security and so on. So we are a global company. We have a huge footprint in US, but as well as in other parts of the globe. So we make sure that we abide by what the local requirements are in terms of supply chain to source it.
Now, Hitachi, you've repeatedly said, is a global company. You have a huge number of employees. I mean, I worked with Hitachi people when I lived in Europe. I've worked with them working here in the US. Um, where does that provide competitive advantage, having a footprint across multiple countries? And, renewable energy isn't an American thing. It's not a uniquely European or Asian thing. Um, what's the competitive advantage a company like yours gets from being in a global footprint?
So I think the number one advantage we have is people. Yeah. So the sheer diversity of the people, the different ways of thinking, the different intelligence they bring in to the table, that is the sheer number one advantage by far. Now, apart from that, of course, we take advantage of the capabilities that we have in the various local sectors, right? So in certain geographies, a certain piece of component or certain piece of material may be more abundantly available, and certain know-how may be more prevalent. So we use those to our advantage to make sure that we have this center of competence, if you will. So we make sure that here we have different center of competences. For example, for offshore wind is one. For solar technologies, we have center of competences and so on. So we make sure that we take the best that we learn globally, but also take advantage of the local infrastructure that helps a particular technology grow and bloom. Really,
So
and
let's,
from
let's
there,
extrapolate that out to your personal experience. You're a North American lead.
yes.
So, how does having a footprint in Europe help you with decisions, let's say in North America, or having a footprint elsewhere? How has that helped impact your renewable strategy for North America?
Sure. So let's take supplying, right? So when we had the supply chain crunch, not just as a company but as an industry uh, during COVID, we had to make sure that we are looking at not just the factories in US but also factories in Europe and South America and so on to source these needs, because those needs were very urgent of our customers, right? So having that flexibility that, hey, we are not constrained by just one toolkit in the toolbox makes a lot of sense, because then in some other parts of the world the demand was probably not as high. So then we could help the take the help of the our European counterparts or our South American counterparts to say, hey, we have a shortage of this equipment here. Why don't you help us? And we could that way serve the customer better.
Now,
Now,
but I guess what that also leads to, if I look at the liberal power markets in Europe and how they operate, and then North American power markets, we're very different structurally.
correct.
Um, so, what what's the differences in the market? So, if we're going to a renewable strategy, and I'm in the EU or I'm sitting here in North America, are there significant differences in strategy, and does that make implementation significantly different?
Absolutely. So, for example, the European market, there's a lot of top-down or vertically integrated players, TSOs, for instance, who take care of a lot of these renewables. So, on the other hand, in US, most of these solar plants, for example, are brought into the market by known as IPPs, independent power producers, also called developers, right? So those are more private players. So there is a significant difference between how the vertically owned TSOs work versus the IPPs work, and hence we have to make sure that we understand the business cases of the IPPs and developers, and accordingly generate solutions that make sense to their market. And this really comes down to customer intimacy. So understanding the customer's pain points and how to make sure that our solutions, for example, we talked about making it future proof, how our solutions can make alleviate their pain.
So if you were to deliver a call to action or ask North American energy leaders, a lot of our audience, what would you be encouraging them to step up and do?
Yeah, I think there's a lot of things that, first of all, are very proud of what we have done in the last few years. That's really a step in the right direction in a lot of ways. What we want to see more is really having this cross collaboration among all the stakeholders. And this cuts across, let's say, OEMs like us, the developers, the utilities, the regulatory bodies, and the government. So, because the key thing here is for the market is to give stability. If the market is stable, it definitely becomes more attractive for these private entities like developers to invest more, and hence make sure that the grid and the generation, the load of all aspects of it grow to the need that serves the society. So I think here we need to work. We are already working pretty close as a stakeholders, but we can do more as working closely so that our plans align with each other. So we have visibility into the planning of what's coming in terms of not just grid enhancements, for example, but also in terms of the pipelines and so on and so forth.
Now, do you see that the driver? I mean, obviously, there's an environmental impact. Is this being driven by economics from most of the developers' point of view, or are there still quite a bit of folks making the decision based on environment? And near term, do you see that being a change, or do you see this being the path to the future? So, is it the economics that these folks are going to say, "Hey, we're going to put renewables in because of the most cost effective way to get a stable grid," or is it we're doing it because we don't want to see 1 point some odd degrees worth of climate change in the near future? Which way on the continuum does that fall?
Yeah, I think it's, as you said, it's a continuum, and I think it's a mix of both. But I think there's a strong aspect. The economics is much stronger today for most projects, if not all. The only reason the developers are investing money is because they have a positive rate of return, right? So today, I'm not aware of any developers who is investing money in a renewable project saying that, hey, I know I won't make money out of it. That's not true. They
No, but
invest.
aren't there funds that are dedicated to going into renewable? I mean, there's earmarked funds
Yeah,
for
there
renewables.
are. Yes, but they are making the reason they're putting that funds together is, yes, there's a social responsibility towards the environment, but also the funds are there to make positive rate of returns, right? So I think if you look back 10 plus years, the economics was not as strong, right? So then those were that's why the traction was lower. So there was lower amount of money flowing into it, and the reason it is much higher today is because the economics makes a lot of sense, and people really believe in the economics, and they have already seen the positive effects of it, and hence they are attracted to the market.
Now, other than just a straight business problem, is there a technology innovation or something that either has recently happened or on the cusp that you see will be transformative for the deployment and the rate of deployment of renewables?
Sure. I think one of the things that there are many. So we are a technology company, so we get to look under the hood and talk to our research colleagues. I was myself a researcher for a dozen of years, so we look at a lot of things that are really truly exciting. But one thing I think that is coming, and it's, as you said, at the cusp, is this grid farming technology. That is really exciting. Really what it is it allows the renewable plants and so on to act as a synchronous generator, if you will. So making it look, electrically speaking, as a synchronous generator, as a big generator, and hence providing the stability to the grid, especially during disturbances and faults and so on. So that's something that is really near term we see as a game changer, because that will allow the grid operators to bring in a lot of renewables more confidently, I would say.
Well, I want to thank you. This has been an enlightening conversation. You're very optimistic about the future, where we're headed, and the change coming. And I want to thank you for sharing with the audience an insider's guide to energy today. It's been a joy.
Thank you, Chris. It has been a pleasure, and hope we do it again soon.
If you're an audience member and you enjoyed this content, please give it a like. Please don't forget to comment and forward it to your friends. And we'll see you again next time on the Insider's Guide to Energy. Bye for now.